Here's a short video on drilling and tapping. Frank places a drill bit into the drill chuck and hand tightens it, and then utilizes a drill chuck key in order to ensure it is sufficiently tightened. He now turns the machine on in order to adjust the RPM to what he has calculated as the appropriate RPM for the drilling operation. Now you'll see the drill chuck turning in a clockwise direction. Frank pulls down on the quill, applies some coolant, and now you will see a peck drilling operation. This is where Frank pulls down on the quill approximately 100 thou at a time, lifts up slightly in order to ensure the drill chips break off and do not wrap themselves around the drill bit. You'll see Frank intermittently spraying coolant to ensure the drill bit stays sufficiently lubricated. At this point, Frank has shut the spindle off. He is moving over to the next hole position. He will then turn the spindle on in a clockwise direction, pull down, apply some coolant, and complete the same peck drilling operation as previously shown. It is important to note that when you're breaking through the bottom of the workpiece, this is when drill bits have a tendency to break. You need to ease up on your feed, make sure you're feeling it with your arm so that you can break through slowly and safely. At this point, you're going to see Frank has installed a countersink into the drill chuck. Countersinks are used to enlarge the top of the hole. They break the sharp edges and they provide an angular lead-in into the hole to help facilitate the next operation, which is threading. You'll notice here that the countersink is turning slower than the drill. Make sure to calculate your proper RPM. Frank is moving now from one hole over to the other. You'll notice he did not shut it off. If you feel safe now, you can do the same thing. Keep it running while you move it from one hole to the next and pull down again in order to countersink the top of the hole. At this stage in the video, we're going to observe Frank removing the drill chuck. So you can see he's loosened the drawbar with a wrench, loosened it a bit by hand, tapped it down with a soft face hammer, and now completes it by hand, removing it. You'll notice now he grabs a collet out of the toolbox, installs the collet by hand into the spindle, tightens the drawbar. He's now going to install a spring-loaded tap guide, continue to tighten the collet, and finish seating it properly with the 3/4 wrench. So the spring-loaded tap guide is installed, and now you'll see its operation. It's here to help align the tap so that we're 90 degrees to the hole that we're going to tap. You can see Frank has applied some lubricant and cutting oil to our tap, and now he twists the tap in a clockwise direction, a few turns, feeling the chips cutting, and then pulls backwards counterclockwise in order to break those chips. The design of the tap is either two ways: one, to push the chips down in the hole and out the bottom, or to make the chips spiral up the flutes like you saw with drilling. The hand taps that we utilize in our shop will predominantly push the swarf or the cuttings downwards, and you just have to make sure that you're constantly turning it clockwise until you feel it get tight, and then counterclockwise to break those chips. Here you can see in the zoomed in view Frank turning it clockwise a couple turns and then moving it counterclockwise in order to break the chips. Once you've got almost all the way through, you can continue to turn it clockwise and then remove it counterclockwise in a nice smooth operation. Here you'll see Frank remove the tap easily by moving the table down away from the spring-loaded tap guide, and in a counterclockwise motion remove the tap smoothly.